All right, so 13.2 is define general angles and use radian measure. All right, so we're going to actually do 3, 4, and 5 all together because it's a matching thing. So kind of defeats the purpose to just do one of them. So 3 is going to be negative 240 degrees. 4 is going to be 600 degrees. And 5 is going to be negative 9 pi over 4. Do I have... Hold on a second. I'm trying to find... Okay, there we go. All right, so basically, I just want to show you really quickly how to, let me see if it'll let me do this. Basically, yeah, how to use it, how to look at it, blah, 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 in terms of counting, and then we'll actually draw the picture so that we can actually do the matching part of the problems that we need. But obviously, going in the positive direction, I think y'all know how to count everything. Okay, if it's something bigger than the value, okay, that's on here, obviously the biggest that you can see is 360. Okay, so if we had like 4 or 390 or something like that, okay, you start here at 0, you work your way around, you get all the way to 360, then you need to add 30 more to get to 390. Okay, so that angle that you're looking for is this one right here. Okay. Then if you had instead negative, okay, then everything is backwards. So if I want you to tell me where negative 270 is, okay, then I'm going to start here. I'm going to work my way backwards. Okay, that's negative 90, negative 180, and then all the way up to negative 270. Okay, so you're still just counting your angles around. Now, degrees, probably relatively easy to think about. So, you know, counting relatively simple with actual numbers. Now, when you get to the ones that are in radians, okay, so these values out here, okay, if I tell you to go to, let's see, 11 pi over 4, okay, we start here, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, then, okay, I want to go a little bit farther, 9 pi over 4, 10 pi over 4, what did I say I was going to, 11 pi over 4? 11 pi over 4, okay, so you just keep going all the way around, okay? So you just keep counting around every time you hit one of those increments, okay? So it's not awful, and then if it's negative, then you're going the other direction. Oh. So you basically, I mean, and you can also, you'll get used to thinking about it where you'll be like, okay, well, 8 pi over 4 would have been here, and then you won't have to count them all. You'll just count the next couple to get to what you needed.
Wait, I forgot. What is increments of, like...
The pi over 4s are at the 45 degrees.
You said 30?
45.
45.
Yeah.
So increments of 45.
Any questions about that? We'll come back to it in a second. So, oh, that's going to open last year's notes. That's not what I wanted it to do. Hello? It decided it's going to have a mind of its own. All right, so the pictures that you're given, now these don't go with the numbers. We're going to be matching them. Letter A is going to be a graph. Here, I'm going to go ahead and draw them all, and then I'll draw what they actually look like on the paper. Alright, so the first one, I'm going to draw them just like they are in your book, okay? I'm just going to copy them. And then they're going to actually draw the line. That's the angle that you're looking for.
This is Quinn.
Hey.
Are you able to pick up real quick, please?
Yep. Hey. You can keep it as Earhart because I don't officially have everything changed over yet. Okay, thanks. Bye. Okay, so obviously those are supposed to be, you know, more like perfect, but whatever. All right, so basically we're looking at these and find a color that's, we'll just try, or here, I'll make it a darker green so we'll be able to see it good. All right, so basically we're trying to find the angle that matches up, okay, with the picture. We're trying to match angle and picture. So if it starts by going down, so this is why the arrows on them are important, okay, then they're going to be negative. Okay, so which two of these have to be negative?
A and B.
In the direction that they're going. It's got to be
I thought
negative.
A.
Okay, so these two are going to be negative, so we know that 3 and 5 have to go with A and B.
Oh, I thought you meant the blue
Okay.
arrow. I was like,
So then with the positive one, okay, coming all the way around one time. So here, coming all the way around one time gives you 360 degrees. Okay, going a little bit farther, that's adding on another 90, which is what, 450? Yeah. Going around another 90 gives you 540, and then we need to go a little bit farther. And so this one is the 600 degree one, okay? So C goes with 4. So then with A, okay, we start here, we come all the way around one full time, okay? One full time around is how many degrees? 360, so it's not possible that it's negative 240, right? We've gone around one full time. Got to go a little bit farther. So going around all the way around one time in terms of pi over 4 is going to be 8 pi over 4, or in this case, because we're going down and around, it's negative 8 pi over 4. We need to go one more pi over 4 across. So this one is going to be the negative 9 pi over 4. So 5 is A. Okay, and then for B, okay, you come around a half time. A half time is how many degrees? 180, going a little bit farther, okay. About 60 more is going to be negative 240, okay, because we went down and around, so negative 240 degrees. So 3 is B. Does this make sense? All right, so then the next one say to draw an angle with the given measure in standard position. Okay, standard position means basically from the x-axis. Okay, it's all that means. So let's start with 6. So we've got 110 degrees. Now, is that a value that we know off of our unit circle? No. Okay, so we're going to be drawing an angle in, and we're going to get it as close to, it asked for 110, so we're going to get as close to 110 as possible. So we know that from our unit circle, it's a little bit farther, okay, than 90, okay, but it's not all the way to 120. So we know it's going to be in that area there. Why does this not? Okay. So, I'm going to draw my graph. Okay, we're going to do everything on the graph to help us see it better. So, we said that we're going a little bit farther than 90. We're going how much farther than 90?
Like 20.
Okay, 20. So, we're going to draw it in. So, then that's going to be our angle there that we're drawing in.
Easy. Not bad.
So then with 8, it's looking for 450 degrees. So I'm going to set it up again.
Gotta go all the way around.
Okay. I've got to go all the way around once, and then how much farther do I need to go after that? I've gone 360.
So 90 more.
Go 90 more. So I stop at the axis. I draw in my angle. Notice that it is going right on top of the y-axis there. That's where my angle is. Okay, so something this would tell you, it would tell you that this angle, the angle 450, is going to have the same values as 90. Okay, those angles are the same. They would give you the same values off if you needed to be solving something. Let's see. Let's do 10. Looks kind of fun.
I don't know if that was sarcastic.
10 is 6 pi. Okay, so something we know about pi, right, is pi is how many degrees? The same as how many degrees? 180. So to go around half is pi. Okay, to go all the way around gives us 2 pi, right? So I'm going to start here. Okay, start here. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So 6 pi is the same as 2 pi or 0, however you want to look at it.
What'd you say? You said it's cute, man. What? It's a cinnamon roll. I'm a cinnamon roll.
It looks like
Wait.
it's like a target.
It does.
Now, I just want to, we're not actually going to do it, but I just want to talk about kind of how we would think about it. I typically won't give you one like this, but number 11 is 5 pi over 18.
Excuse me.
Now, the question is pi over 18 something that we have on our graph? No. But any ideas how I would figure out what that is?
You could like multiply the 6, like the pi over 6 or something like that. And like make the bottom denominator 3. I mean like times 3 or something, equal 18 maybe. I don't know.
So let's think about this really quick. So I've got, okay, my nice little graph here, right?
Yeah.
So to get from here to here is pi, or 180 degrees, right?
Right?
Now, 180 degrees, okay, we've divided it up into increments, right, to give you our pi over 3s, our pi over 6s, okay. When we're counting in pi over 6s, how many degrees are every pi over 6? How many more degrees are you going?
30.
Okay, 30 degrees. So, if I divide 180 by 6 to give me my pi over 6, that gives you 30, correct?
Yeah.
30 degrees. So, if I have 180 degrees and it's divided up into 18 parts, how many degrees is each of those?
10.
Okay, so these are going to be in increments of 10 degrees. Okay, so you would have something like every 10, so let's see, that's not going to be 10, that's like 20. 10, 20, 30, 40, don't mind my crooked lines. 50, 60, 70, 80, 90, okay? So you see how it breaks it up into all these little individual pieces. So then you would have to take, and you'd have to go, okay, well, I'm going 5 pi over 18. So 1, 2, 3, 4, 5. Okay, so this would be the same as 50 degrees. Okay, so you would have to break it up into smaller increments. Definitely something you can do. Okay, I typically don't give you those just because it's very hard to draw them, because obviously you can see you're trying to basically play a guessing game as to where to draw them. I'm more concerned that you can count by the known values, the pi over 3s, pi over 4s, pi over 6s, okay, things like that. If it was, you know, some kind of pi over 9, we do it the same way. We do the 180 divided by 9 and figure out what increments it goes in to do that. And then, obviously, if we did increments of 9 pi over 9 would be here, and then we would keep going around. So this would be 18 pi over 9, okay, and then you would just keep going around in groups, okay? But again, don't stress about those ones too much. That is not what I'm overly concerned about in the slightest. Let's see. All right, so the next thing says to, I'm going to actually write these down. Find the coterminal angles, what should have been talked about in the notes, but this is finding one positive angle. So one positive angle and a negative angle, okay, that are coterminal with a given angle. So what does that mean? Okay, what I talked about up here, right, was that 450 degrees is the same as 90 degrees, right? Okay, those would be coterminal angles.
Because they have like
Okay.
the same values.
Yes, because the values would end up being the same. So here's what I'm going to tell you. When you're finding coterminal angles and it asks for the positive and negative ones, I don't want you to tell me that negative 720, okay, is the same as 0. Okay, 316, 360, 720, right? I think so. Okay, I don't want you to tell me, you know, go out and find some obscure one. I want to know the first one. Okay, so I'm going to show you what I mean by that. But I don't want you to go find this obscure angle. I'm looking for the one that's closest to the value that you're given. So don't, you know, do it like 3 times and be like, oh, this one's coterminal with it. Like, first of all, why would you do extra math that you don't have to do? And then, 2, it's just, you don't need to do that. So, we're going to start with 16. Okay, we'll do a couple of these ones. 255 degrees. So, when I want to find angles that are coterminal with it, what I do is I add 360 or subtract 360. It always goes in groups of 360. So to do the first one, I'm going to do 255 plus 360. So that's 5. Let's see, was that 11? So 615 degrees. Okay, would be my positive one. Okay, this is my positive answer. So then to do my negative one, okay, I can do, obviously, I could just copy this over and do 255 minus 360. But what you may want to do instead, if you're going to actually set it up this way and write it, is you may want to actually flip them and do 360 minus 255. And then just know that the answer is going to be negative because you were fine. You know what I mean?
Yeah.
So then you can do, you know, your normal subtraction. So what is that? Negative 105. Okay, so that's going to be your negative answer. So 615 degrees and negative 105. Okay.
So it's really easy.
So those would be your 2 coterminal angles. So what I'm telling you is I don't want you to add another 360 and then tell me that 975 is coterminal. Yes, that's true, but I want the smallest one. Okay? Now, I will show you this next problem is going to be one where I'll show you what, there's actually going to be two possible options that I would accept for it, okay? And how you would, well, I guess technically there would be three for this one, but we'll talk about why I'll accept all of them. All right, so 18 is 820 degrees. Okay? So, if I want to find a positive, okay, I can add 360, right? So I would have 820 plus 360. So that's going to be, what is this, 1180? So that's an option for positive. However,
Not gonna be
right, so that's where I'm going with this one. There's a lot of options for this one. So I say I want the closest one. Well, obviously, if you follow the typical instructions of coterminal angles, it says add 360. You just added 360, so I'll take that one. Another option is you can do 820 minus 360.
It's still positive.
It's still oh, that's numbers.
Oh, wait, why did I do that? I don't need to do that.
It's just numbers.
6.
Well, I still only took one out of the two because for some reason I forgot to do zero minus zero. You don't have to.
So 820 minus 360 is still a positive angle, right? 460 degrees, so that's another positive one I would take.
Okay.
I will typically say if you have a number that's bigger than 360, go with an answer like this over this one because this one here is going to lead to extra work, right? Because you're going to add it and then you're going to have to subtract because you've got to get down to a negative value. Okay? Now, I'm still not at a negative value, a negative angle, so I got to do it again. 460 minus 360. It's 100 degrees, which you would agree, I would assume, is another possible positive answer. Okay, so all of these are possible positive answers. Okay, that I would accept. Okay. Now, I'm going to subtract 360 again, okay, or I can do 360 minus 100 and just know that my answer is going to come out to be negative. So 0, 6, 2. So negative 260 degrees is my only negative option. Okay, so I would take any of those positive answers, okay, and then that one negative answer.
Wait, you said take all three of those possible answers?
Yeah, you can write any of them.
Oh, okay.
So I would probably not actually ever do this first one just because, like I said, it's more work. I had to go through and do 3 sets of subtraction to get down to my negative.
Already, and then
But if I had just, so I could have gotten rid of that one and only had to do 3 things. If I do this one, then I had to do 3 more, so I had to do 4 total. Now, is this hard math? No. But I'm all about saving time, so if I can save time, I'm going to save time. Okay? Now, we did that with degrees. Another option is to do it with radians. However, most people don't like counting in radians. Okay? Certainly not having to do it this way. A lot of times what I'll do if I'm doing radians is I will actually convert it to degrees, which we haven't learned yet. We're going to do that in a minute. I'm going to show you how to do one, leaving it as radians, okay? And then I'm going to show you, after we learn how to convert, how to go back and do this doing it as a conversion, okay? And what that's going to look like. I don't mind if you convert them to radians, from radians to degrees. If you just feel more comfortable doing it with degrees or you think it's easier. But that does require another step of math to do it. So, I'm going to do 20, leaving it as radians. And it's negative 7 pi over 6. Okay? So, 360 degrees is the same as how many radians? 2 pi. Okay? So, I need 2 pi. But, I'm adding and subtracting, so I need a common denominator. So how many pi over 6 do I need to make it equivalent to 2 pi?
oh wait,
Okay, so I'm going to use
Yeah.
plus or minus 12 pi over 6. So I'm either adding or subtracting 12 pi over 6. I don't know why my 2 has a nice little tail on the top of
So
it.
that's the equivalent of like 36.
Yeah.
Okay.
So for radians, 2 pi is the equivalent of 360. Okay, now because, like I said, it's pi over some number, you've got to figure out what it is that gives you 2 pi, the equivalent, okay? So what I can do here then is do negative 7 pi over 6 plus 12 pi over 6, okay, which is going to give me what?
5 pi over 6.
5 pi over 6. Okay, so that'll be my positive one.
Whoop-de-doo.
Now to do the negative one, it's negative 7 pi over 6 minus
I mean, minus.
12 pi over 6, which is
Negative 19 pi over 6.
okay. So still not bad. It's just if you really hate fractions, you probably aren't gonna like doing it this way. Not that it's like hard because you're not really like solving anything down. And obviously, if you got an answer that could be reduced, reduce it. But you're not typically gonna have something that's reducible. So actually, let's just say for this finding coterminal, let's leave it. Don't worry about reducing it if it is something that can be reduced. Because typically, it's actually going to have reduced here just because of the way that it's going to work out. So I'm going to save 22 until we've done conversions of degrees to radians. Okay. Well, let's see, where are we at? So, all right. So the next thing... Or here, actually what I'm going to do is I'm going to leave a spot for 22. It's going to be 20 pi over 3. Okay, so we're going to have a conversion. So leave like 4 or 5 lines, something like that. The conversion will take 2 lines, and then however long those took you, or however much space you took for those. So the next thing we're going to do is convert degrees to radians or radians to degrees. Now, I'm assuming y'all have done conversions with Miss Marshall at some point, yes? Okay, we're going to do it the same way,
Have we done degrees to
okay? You wouldn't have done these yet, but you've just done general conversions with her, okay? So the instructions say to do one or the other, okay? You have to obviously know which one you're starting with and know that you're going to the opposite one, just like for some people that's not super clear, so I'm just letting you know now that's how you do it, okay? So 24, 315 degrees. Okay, so I'm starting with degrees, so I'm converting to radians. So this is how I set it up. 315. Okay, now the conversion factor for degrees to radians is pi over 180, or from radians to degrees, 180. I can't write today apparently. 180 over pi. Okay? 180 is obviously in degrees. We want the degrees to cancel and leave us with radians. So, in this case, I'm degrees to radians, so it's times pi over 180. This is the thing. We never multiply the pi through with these conversions. Your answer, when your degrees to radians, is always going to have a pi in it. So your answer is going to look like some number times pi. Okay? So, basically, all you're doing is reducing. So you're not going to say, okay, well, 315 divided by 180 is... 315 divided by 180 is 1.75. You're not going to tell me that either. Okay? You're simply reducing. So we're going to take out as much as we can, okay, to reduce it down. So what is something you think we could possibly take out of both?
Definitely.
Okay, definitely a 5. So if I take a 5 out of 315, just to save time, I'm going to do this really quick. Okay, if I take a 5 out of 315, I'm left with 63. Okay, so 63 pi over, now 180 divided by 5 is 36. Is that reduced as far as it can go?
No.
No. So what else can I take out?
A 9.
Yeah, so a 9 coming out, leaving you a 7 pi over 4. Okay. Now, as you go, you'll kind of get used to what you can pull out of stuff, and it'll like help it make sense. Obviously, if you had, let's say this was 300 and 180, you can cancel a 0 out of both right away, and so that'll help you, you know, with canceling stuff.
Can we just get thing on 22?
Yeah, we're going to come back to it because I'm going to do 22 by converting it from radians to degrees, and then we're going to solve it like we did 16 and 18. All right, so then 26 is 500 degrees. So I start with degrees, so I have 500. Degrees to radians is pi over 180, okay, which makes the units cancel. So now I can cancel out a 0 from both because they both end in a 0. So I can get rid of that. So 50 pi over 180, what can I take out of that?
You can take out A2.
2.
Two,
So
I
I'll use
guess.
25 pi over 9. And can that reduce any farther?
No.
So then you're done.
My squared looks like a crap.
Okay, so degrees to radians, not too bad. I want you to really pay attention to radians to degrees because I'm going to show you what people tend to do. Okay, I'm going to show you, first of all, how to do it correctly, and then I'm going to show you what people tend to do and why it's not right, okay? Or why people end up getting them wrong when they do it this way. So 28 is negative pi over 4. I'm radians to degrees, okay? So I'm using 180 over pi this time, okay? Because I want degrees on top. So negative pi over 4, okay? And then 180 over pi.
So the pi's can cancel, right?
The pi's are going to cancel. Okay, leaving you with, can I take a 4 out of 180?
You
Yes.
can.
What is it equal to?
1, 4,
45.
Okay, so don't forget the negative sign, so it's going to be negative 45 degrees. Now, I'm going to show you what people tend to do and why they get it wrong when they do it this way. What I see a lot of times is somebody will write, I'm just going to go ahead and write wrong way. Okay, after I'm done, I'm going to erase it because I want to get rid of it. I don't want you to be able to go back and look at it.
I'm not even gonna write it.
Yeah, I wouldn't write it because I don't want you to get confused, but I'm trying to caution you because I see this every year, and it's what happens when people end up getting it wrong. So they'll go negative pi over 4 over 180 over pi.
So then there's a 4 with the.
So in reality, it shouldn't throw them off because the 4 and the 180 still cancel, the pi and the pi still cancel. But what they inevitably do is they'll somehow cancel the pi's and then they'll multiply negative 4 times 180.
Yeah.
Okay, so then they'll get negative 4 times 180 and then they'll come out with some answer and then they're like, why did I get this wrong? And I'm like, well, because you didn't set it up the way I told you to. Okay, so I'm going to get rid of it. Don't do it that way, okay? Do it the way that's written in blue,
Erase it from
not,
our mind.
not the way that's written in red, okay?
It has been forgotten.
You have been warned. Okay, don't do it. All right, 30. 14 pi over 15.
We get a little big.
So 14 pi over 15 times 180 over pi.
Cancel the pi.
Okay, so pi's are gone. We said that 15, or well, how many times can 15 go into 180?
Once. Wait.
Wait, no.
What?
not what I meant.
No.
That's not what I meant. It's
But once.
12 times.
Yeah, 12.
Okay, so that cancels,
One time.
leaving you with 12. So now I just have 12 times 14.
So it would be, wait, I got it. I can do it. 168.
Good job.
Yeah.
168 degrees for that one.
Well, what I was saying,
I know
because
what
I
you're
was
saying.
I was dividing it in my head, so I did the 15 goes into 18 once, and I said it out loud.
You're supposed to stay in my head.
All right. Let's go back and look at 22 now. Okay.
How to do it.
I'm going to do this one again by conversion just so you see it. And that way, you know what I'm doing. So, 20 pi over 3, okay, we talked about with 20 how you could do it by using radians, okay, you would need to use 6 pi over 3 being added or subtracted if you want to do it that way. Always fine to do that. A lot of people, just because they don't like fractions, want to do the conversion. So we would have 20 pi over 3 times 180 over pi. Okay, so pi's cancel. 3 goes into 180 how many times? 60. So you're left with 60 times 20, which is going to be 1,200, right?
Yeah.
Yes.
Okay. So then now you need to add or subtract 360. I'm not going to do the adding option because I don't want to have to do extra math. So I'm going to do that minus 360. Now I'm going to show you another option of what you can do here. So we'll do this one first.
There's things you can't do.
If you like this way and that's your content, then okay. So 840 is a positive option. Let's say you realize at this point that you're going to have to keep subtracting several more times to get to your negative 1. But let's say that you know that 360 times 2 is 720. And you know that if you subtract that, you're still not going to be there. What you can do is you could say, okay, 360 times 3 is going to give me, what is that? 1,080. Okay. So you can take 1,080 minus 840, 0, 4, and negative 240 would be your first. I just wrote over top of that. Negative 240 would be your first negative 1. Okay? You can do it that way if you so desire by multiplying increments of 360 so that you don't have to worry about that. Okay? Obviously, every time we subtract 360 until we get a negative number is another positive option that you can use. Just since this one's really big, didn't want to do it. Let's see.
What time is it?
We only have like a couple minutes left. Here, one more thing here, and then there's one thing left that we'll have to do on Tuesday. Okay, Monday I'm gonna assign you problems to do. But what I want us to look at really quick, okay, if I tell you to tell me what the sine of pi over 4 is, okay, from your unit circle, you're looking at the y value at pi over 4, okay?
So it's square root 2 over
So I'm at pi over 4. I'm looking at the y value for sine, okay, which is the square root of 2 over 2. Okay, so the answer, root 2 over 2. Okay, 44 cosine of pi over 6.
Oh, I got this one. I know this one.
Okay, so I'm at pi over 6. Cosine is the x value.
Yeah.
So it's root 3 over 2.
Easy.
Okay? Root 3 over 2. Okay? We'll talk about what happens because what we're going to also look at is something like 42 where it's the secant of pi over 9. That's not something that we know. Okay, so we'll talk about how to find that next time. But in the meantime, I'm going to get rid of this and write the problems that I want you to work on Monday. Okay. Monday in class. I want you to do problems 15, 17, 19. I want you to just try 21. That's finding the coterminal angles for something that's not a known value. It's a pi over 9 option, okay? And then for conversions, 25, 27, and 29. Okay, and I'm giving you more because you're going to have a whole class period to do it. And then for just making sure that you're reading a unit circle correctly, 39, 41, and that's it. Okay?